All right, welcome tonight. Everyone get some food and drinks, so we'll get started a few minutes late. My name is Joseph Wei. I'm the chair for the Consumer Electronics Society for the Santa Clara Valley, and welcome all of you to come. Tonight is interesting. Instead of a typical tech talk, we have a panel with a combination of investors' perspective and also from the actual hardware startup to talk about the hardware startup and innovation systems. So this is the agenda, and each of the speakers will give a 15-minute presentation about what they do. And depending if they really can fill up the 15 minutes, maybe we can take a few Q&A at the end of their talk. And then we'll have a panel discussion afterwards. And I have a few questions, and I think usually a panel discussion is more interesting when we take questions from the audience. So I'll also open up the Q&A part to the audience after 8 o'clock. A little bit of logistics. The bathrooms out this door to the left, and then I think that's about the only logistics I have. Maybe we'll switch to the other slide. So then we have a website that we keep pretty much updated. So all the past, after tonight, if the speakers are okay with the presentation, I know one speaker said they cannot actually even show slides at public events. So they'll be posted up in the website, and that's the URL you can find all the previous presentations. So if we have young people in our crowd who would like to do Twitch, these are the hashtags that we have. This is the roster for this year's officers. So I'm the chair, ranking. He might be still outside checking in people. He's the vice chair. Contact is not able to make it. And then Shamir, I think, is over at the VM World Conference in San Francisco, so he cannot make it. I think bottom row we have Eric Kwan Lee. He's also, he actually works and lives in San Francisco, so he doesn't come down too often. But if you have any organization you'd like to partner with us for a joint event, please get in touch with Eric. And Jeff is also tied up. He's the program chair who will organize a lot of these speakers events. Vin was here, or maybe he's still outside helping with the check. So Vin is one of the program committee members, as well as Krishna. And we're also looking for a membership chair. So every year we run through officer elections, so it's going to come up very soon, in sometime in, I think, early part of October. And will be complete by the end of November. So if you're interested to run as an officer, volunteers, just send me a note and what you'd like to do. So the officers are the official officer position that require election to be elected in. The chair, vice chair, the secretary, and treasurer. So a lot of the other positions are appointed by the chair of the chapter or the office committee after the fact. And this gave a big round of applause for Steve. And Neil, I think to be able to use this wonderful facility, they have to stay with us the whole night. And also in preparation of some badges, because this is security rooms, that's why they have to check your ID. And the next meeting we already set up, so we have speaker Michael Wang, who used to be one of the officers for the C Society. He's going to be talking about autonomous driving and memory system consideration. That's going to be, so our normal meeting for the newcomers is always the fourth Tuesday of every month, except November and December. So November, because it's Thanksgiving, Tuesday is Thanksgiving week, so we don't hold any meetings usually in November. And then December, we move it to the first week, so it's first Tuesday of, so you can just check the website, or and the website actually has a link that you can subscribe to our email list. And I think we have, just a quick show of hands, because I think through Eventbrite we kind of know. How many people are IEEE members? All right, so we have very high turnout for IEEE members. And how many are CE members? Probably 1/3. Yeah, that's great. So this some for the information for some of the not people who are not joined IEEE, so we can actually join as a student or as a professional member. And then there's another thing, if you just want to try and see how you like it, there's something called affiliate membership. So affiliate membership has some limitation. You don't get the Spectrum magazine, you cannot run as officers, but then you get basically the same benefit as a member now. So you can come to the CE meeting for free, you still get on the email list and everything. And then for membership recruiting, for the people who are already a member, and you help out with recruiting other members to join, so you can actually get earn credit up to $15 for professional membership and $5 for e-membership, and that can be applied towards your renewal for your membership fee for next year. So C Society will publish, you get 2 magazines. One is our own, the Consumer Electronic Magazine, which received an award in 2016. And then is the I3 magazine, which is published by the Consumer Electronics, actually, I should update that. They now renamed as Consumer Technology Association. If you have any speakers you'd like to bring, nominate for future events, you may send an email to Jeff, who's the program chair, and this is his email address. And if you have a joint event, please email Eric. And here are the upcoming events. And eGrid is the website, and also they do 2 emails per month that contains all the IEEE events in the Bay Area. So it includes San Francisco and Oakland East Bay, as well as Santa Clara Valley. And then Casper actually is the partnering organization. They focus on semiconductor, and we do joint promotion of each other's events. There's a couple actually how we're oriented. One is actually I run the meetup called Silicon Valley Wearable Meetup. And then the other one is how we massive meetup, and then the product realization group. So a lot of these meetup groups are really focused on consumer electronics hardware products. So I thought we'll highlight them to you. And then product realization group will have the annual conference at the museum. I have a little more detailed slide for you. And then October, in this last quarter of the year, there's going to be a whole bunch of annual conferences by different organizations. Casper is going to have theirs on October 13, and then we also have a whole Humanitarian Technology Conference in San Jose in October. And then for the IEEE chapter members, there's going to be a central area meeting for the officers in October. And Brian, you want to come up and say a few words about your conference?
Very quickly, hi, I'm Brian Johnson. I chair the Power Electronics Society panels. And I just want to let you guys know that there are some flyers in back. We have an event coming up next month on Wednesday the 19th, a very unique one-day, full-day tutorial. It's called the 5G Energy Efficiency Tutorial. And essentially, there's lots of 5G related events. This isn't about market projections. This isn't about channel modeling. This is about a real issue today that all these projections are broken the way they are today because there simply isn't enough power in the world to power the billions or trillions of devices based on the standards we have today. So this is all about an excellent lineup of top-notch speakers covering all aspects of network, from edge stuff to everything. So whether you're involved in 5G or power or not, if you're involved in IoT wearables, autonomous vehicles, AR, VR, pretty much anything that will touch the 5G network, that this content is highly applicable to you, and I promise you it will be a very eye-opening and very educational, worthwhile event. So if you're interested, you register now, find a flyer and back, and come talk to me. Thank you very much.
Thank you. So the one put up earlier, you have something there?
Oh, yeah.
Okay, so let me finish these two and now bring up. Is the annual conference for the product realization groups. They are going to be holding it at the Computer History Museum. So you have a few more days to sign up for the 15% discount. So they will have about 15 hardware demos and 300 people on related in the hardware ecosystem there. And then the next thing is the Global Humanitarian Technology Conference. So if your company has actually, because a lot of companies like NVIDIA, Intel, Qualcomm, you all have some kind of corporate social responsibility and related project that you want to join this conference to highlight some of the contribution that you have made towards using technology to resolve some of the humanitarian challenges in the world. And that's going to be in San Jose in October 18th to the 21st. And here are some of the previous companies who are sponsored and exhibited the talk. And Fred, you have something too, right?
Yeah. Thank you. Thank you very much. I'm Fred Stein. I'm with an organization called VLab, VLAB.org. And we're putting up an event that would be a good follow-up to this. It's about the use of RISC-V and how this is going to enable a whole new generation of chip vendors. And in fact, the S5 organization will be on our panel. So these events are held at Stanford in the faculty club. They're $35 right now. The price will go up in a short while. And we will send all you guys a discount code. Yeah, so you'll be able to get $10 off the price. So again, Stanford Faculty Club, VLAB.org, RISC-V. Thank you very much. And I got a few flyers if anyone wants to grab one.
So if any company is hiring and you want to make a quick announcement, you can raise your hand. I can pass you the mic. No? Nobody's hiring? You got all the engineers you want, huh? All right. Next is, if you're seeking full-time employment or part-time employment, anybody wants to give 1 minute? Everybody is happy to what they. Oh, here.
So I'm the first one.
All right.
So SiFive. SiFive is always hiring.
Okay. So you want to say what you're looking for?
So hi, my name is Jack. I'm on the panel from SiFive for the RISC-V guys. You'll pretty much learn what we're doing after I talk. If that sounds interesting to you, we're hiring all sorts of folks. We really want people who know both software and hardware, so using software to write hardware. So new design techniques, everything. There's a fit for everybody.
Thank you. So, I think that's it. Next up, yeah, Willow, you have something to say about White Young Professional?
Hi everyone, my name is Willow. I'm the chair for IEEE Santa Cruz Young Professionals. I'd like to welcome you to tonight's program of IEEE Startup and Innovation Symposium. This event is organized by IEEE SCV Consumer Electronics Society, Young Professionals, and the Solid State Circuit Society. So if you enjoyed today's program, please check out our other events by visiting our website. And we have events on a monthly basis. So we organized this event with the observation that the past year saw tremendous growth in the hardware startup arena. So I think this is a truly amazing time to be doing hardware. Perhaps the biggest drivers for the recent hardware development are artificial intelligence-enabled ASICs, as well as the new architecture RISC-V. And we're fortunate here tonight to have startups in both fields to be with us tonight. So the first half of tonight's program is a series of lightning presentations. Then the theme of the event is innovation and startup. We invited two well-known chip startups, krtkl and SiFive, to share their journey of entrepreneurship. We are also fortunate to have two VC speakers from UC Capital and SK Hynix, who will be talking about the recent trends in hardware innovation from a VC perspective. The second half of tonight's program is a panel discussion moderated by Joseph Wei. Joseph is a partner at SkyChee Ventres and has experience managing multiple incubators and venture labs. So I'd like to welcome our first speaker. Our first speaker is Mr. Ryan Cousins. He's the founder and CEO of krtkl. Ryan is an alumnus of UCLA, where he obtained a BS in mechanical engineering. He's worked in the health tech industry, where he cut his teeth researching and innovating new products in the biomedical field. His R&D experience led him to the to develop embedded systems for medical device, consumer electronics, and mechatronics. He founded krtkl with 2 founding members they share a vision for solving complex problems engineers face around integrating microprocessors in IoT systems. Their first platform, Snickerdoodle, is a prototype to production platform for empowering robotics, drones, computer vision, and beyond. So without further ado, let's welcome our first speaker, Mr. Ryan Cadet.
All right, good evening, everybody. Thanks for coming to listen to my little spiel here. Again, thanks for that intro. My name is Ryan Cousins, CEO and co-founder of a company called krtkl. Don't worry, if you look up krtkl online, you won't get any other results because we're the only company in the world that spells krtkl that way. I'll get into a little bit about what we do, a little bit of our background, sort of into where we're going. I won't spend too much time. I think we have some good questions lined up on the panel for kind of looking into the future, that type of stuff. But just kind of wanted to give some people some insights into what it's like to start a hardware business. We're in a very unique space in hardware. We're above the chip level, but below the system level. We're in, obviously what we call embedded systems. So kind of providing the technology for people building end products. So what do we do? The best part descriptor of the technology we provide is hardware accelerated embedded intelligence. Embedded intelligence meaning we're making pretty small systems, subsystems that go into bigger systems. The hardware accelerated piece is, if people are familiar with FPGAs, field programmable gate arrays. It's basically between a full-blown, it's sort of like a prototyping platform in a sense for ASICs, fully custom chips. So what we're doing is using some products from Xilinx, these little ARM FPGA-based SoCs, to bridge that gap between traditional microprocessor architectures and full-blown custom chips. So you can use that technology to accelerate existing algorithms, and I'll get into a little bit about the background and kind of the advantages and disadvantages and all of that kind of stuff. So the founding team is myself, my co-founders Jamil and Russell. 3 of us worked at a company previously doing mechatronic and electronic designs for a medical device component manufacturer in the Bay Area. We eventually left that company to do some consulting, and what we did during the course of that, kind of how we came to start this company and kick this product off, what we found was in the process of doing all this embedded system consulting work and system development is we kept on solving the same problem over and over and over again. And that it all kind of started from this fundamental piece of basically, I guess what you could call the brain. So what we wanted to do was kind of commoditize that in a sense. And what we found was, there was never, all the solutions out there were either too high end or too low end to fit into these, medical and industrial and commercial systems we were developing. We're not going to use a Raspberry Pi medical device, and we're not going to use some $10,000 development platform in an embedded video module. So what we wanted to do is bring kind of that higher end technology to a more kind of accessible price and usability standpoint. We started the company back in 2014, and we launched our first product, which I'll mention here in a couple minutes, in 2015 as part of a crowdfunding campaign. We'll throw out there, if you're interested in learning some of the trials and tribulations of both crowdfunding and running an embedded system startup, you can check out our website, krtkl.com. I think it's like one of the first videos on there. I gave a talk a few weeks ago about all the ways that we've crashed and burned when it comes to basically getting a product from concept to production. Not even necessarily mistakes that we've made, although there's plenty of those as well. But things that you might not necessarily think about during the course of building a product and what kind of goes into it to get it actually in customers' hands. So anyway, you can check that out if you want. 2016, we got our first hardware, went into production in 2016, 2017, and part of our whole business model is based on other people designing our product into their product. So we got our first OEM application in 2017. In 2018, we've been busy scaling, getting into distribution, building out the product line, all that kind of stuff. And going forward, we're getting more into kind of end system development, more kind of AI-focused hardware to do even more energy efficient algorithm acceleration for these kind of higher end applications. When you're developing the kind of systems that we're typically dealing with, arguably the three biggest pain points are power consumption, performance, and integration. So, like we just mentioned a couple minutes ago, this upcoming event, the 5G event, power is a huge factor in all these edge devices, and not only edge, but even the transmission of the data across the network. So you want to lighten your bandwidth, the amount of data you're sending over the network as much as possible without losing a bunch of data in the process. And while you're doing that, performance at the edge is becoming more and more important as more people are looking to elevate the amount of computation and capabilities of these end devices. And integrating these systems, especially when it comes to mechatronics, where you're tying together, not only just actuators and motors, things of that nature, but sensors and cameras and microphones and all these different things. What you run into a lot of the times is integration problem with these traditional architectures that are very fixed once you get them out of the box. So you eventually run out of a lot of I/O and flexibility and capabilities to tie all those pieces together into one coherent system without making a gigantic mess of all the software. So what we did is took that whole problem and solved it with this thing called Snickerdoodle. It's kind of hard to appreciate the size of it because this is blown up, 40x, but it's the size of a business card. And it's, like I mentioned before, it's got an ARM and FPGA SoC on board, Wi-Fi and Bluetooth, memory, a supervisory microcontroller, and a bunch of I/O. So there's 180 reconfigurable I/O on there, in addition to a bunch of grounds and stuff like that. So it's really kind of targeted towards a combination of mechatronic and high bandwidth applications. But what we've seen with using an FPGA-based solution as opposed to a traditional GPU or microprocessor, microcontroller, is you can get significant performance improvements in terms of compute per watt. So basically, the amount of horsepower you're getting compared to the amount of energy it's consuming. The acceleration of these different algorithms, if you can take basically a completely software-based approach and reconfigure that to run on dedicated hardware without going through the effort of spending, tens, hundreds of thousands of dollars or millions of dollars on running your own ASIC, you can get, 5 to 200x, sometimes more acceleration on, things like computer vision, mechatronic control, things like that. The I/O flexibility is a big element, like I was saying, when you're actually developing the system, but the reconfigurability is really interesting because we're in such a rapidly evolving environment with all the AI, machine learning, and all these cool things people are coming up with every day. Having flexible enough hardware for you to optimize that even after your product shipped or during the life cycle of the product is a huge advantage, both competitive and technology. So, like I mentioned, the two kind of core categories the systems fall into. I'll get into a couple of brief use cases in a second, but are generally speaking mechatronics, so big automated systems, industrial automation, even medical devices, mobile systems, or high bandwidth stuff like computer vision, networking, communications, those types of things. One example of a product that we helped commercialize that was based on Snickerdoodle is this company in Australia built this video networking box where basically they're just bolting this thing to the side of the camera in a broadcast type environment like a studio and doing the real-time video encoding to take those signals and send those out over an IP network. And what they used to be solving this with is some gigantic, desktop thing that sits on the floor, costs $10,000, because they were running a traditional x86 architecture, and they had to have so much horsepower behind it to actually get the kind of throughput that they needed. They wanted it to be portable enough where you could literally just bolt it to the side of a camera and walk around, the studio with it. So that was sort of an implementation where you're taking a software-based approach, turning it into basically a hardware-based approach without doing a full-blown custom chip run, and then making that embedded and turning out, 1,000 of them a month or whatever it is. Another, on the mechatronics side of things, this is kind of not the greatest picture in the world, but this is a multi-axis motor control system that we built for a Chinese motor manufacturer, where they basically wanted to take a single hardware platform and control 6 axes, Brussels TC axes at the same time, and then run, because it's got the ARM core is on the SoC, run the path planning and Linux and all the networking higher end stuff on the ARM core. So you're doing the real-time signal processing, motor control, and the FPGA, and the running ROS and Linux and all this other nonsense on the ARM side of things. So this is kind of a cool one-chip solution where, as opposed to some of these alternative methods that you might end up with like 7 different processors on a board, and then you have to network them all together, you have performance degradation and all sorts of other problems. Another part of what we do, kind of getting toward the end here, but another part of what we do is engineering services. So to kind of both not only keep the lights on, with a cash-strapped startup, but also to have some long-term benefit of helping people actually design our products into systems. We, do hardware, software, and system development for companies who are looking to build systems like these video conversion boxes, mechatronic controls, computer vision, all types of things. We basically do perform that service to help people, like I said, integrate our product into their devices. This is one of the things that we're always looking for. Because we're such a horizontal company in terms of the markets that we touch, because the system, the kind of fundamental product that we develop is so generic. It was kind of a tight spot to fit it in, because you don't want to be so generic that it's not useful, but you also want it to be flexible enough for a bunch of different people to be able to use it. So by extension, we get exposed to a lot of different industries. So we're always looking for different, new advisors who have specific knowledge in individual verticals that we can work with. Investors, of course, who are in the early stages of a new funding round. New systems and projects for people to work on and work with, as well as partnerships. IBM, Xilinx, and ARM, and a few of these other guys that we're already partners with. We're also looking at getting into education as well, because our platform is kind of ideal for that. Like contact info is like somewhere. Oh, this is kind of crazy. All right. That's pretty wild. So my contact information is in the corner there. So cousins@krtkl.com. If anyone's got any questions, I think we might have a couple minutes for questions. I'll be on the panel later. But yeah, I mean, and I'm willing to sit and just hang around and talk to people about, if they have specific questions about startups, what it takes, advice, criticisms, whatever. I'm open to discuss anything with anybody who's got any questions. So anyway, thanks.
Otherwise, we'll save it for
Anybody got?
Yeah, how would you guys compete with Microsoft Azure or like those cloud providers? You're running cloud, you're at the edge, right?
Yeah, right. Yeah, so the question was how do we compete with cloud providers, Azure and stuff. So we would interface with them on the back end. So we are at the edge. Pretty much, I mean, we've looked at down the line getting into something that's kind of one step closer to being on the back end. With more kind of like the high power AI hardware. But generally speaking, these are all this stuff's implemented in devices. So most of the people using our products are, OEMs and device manufacturers. So, if we're in a lot of those instances, people will use our hardware to parse the information coming in and get it into a consumable or pared down form that then you can send out over the network to a back end and then do whatever you're going to do in the cloud type thing.
I think essentially for like Microsoft Azure, they do the data analytics and everything, right? So
Yeah.
you don't have any connectivity piece, right? It's just standalone.
Well, connectivity in terms of you can send the data over the network, or mesh networking and all that kind of stuff. I mean, the problem is with a lot of real-time systems, cloud processing isn't really useful for you. I mean, you want to say if you're running a connected factory, there's a certain element of that where you want to harvest all that data so you can do predictive analytics and maintenance and all the rest of that stuff. But something's got to run the robots, So, you can't have motor control happening, over a 2,000-mile long wire kind of thing. So, when you're talking about, microsecond loops and stuff like that, so those are, a lot of our systems are safety critical, mission critical type stuff. But and at the same time, the other issue with just if you have, like I say, another example that isn't necessarily a hardcore mechatronics application, but if you have like a security and surveillance system, it's not really practical to just stream, like 18, full HD cameras over your broadband to some AWS farm in Nevada or whatever. It's just going to cost you so much money, and it's like just unnecessary use of power. If you can offload as much of that processing to the edge as possible, you can have huge cost savings and huge performance improvements in the long run. So that's the piece that we're taking off. We're taking a lot of that load off of those a lot of the data processing on the back end.
So I'm pretty sure like Azure, they have the product already for IoT. That's the processing and sensor IoT. But like probably attacking a niche one.
Yeah, I mean, it just depends on what you're doing. I mean, if you're, there are certain, power performance envelopes that specific applications have to fit into. Of course, like, there's a million different, applications out there. But yeah, I mean, it really just kind of depends on, there's no point shoehorning, extra horsepower into something that you don't need. But, you need real-time performance, kind of higher performance stuff, a lot of parallel processing, more intensive facial recognition or object detection, or you need to integrate that with the system, or all these different things. There's some severe limitations to just like sticking some $3 microcontroller on there and just hoping that, just waiting for the data to come back. There's definitely a broad range of applications for all this stuff. Yeah, good question.
I think that's all the time we have.
Oh.
So we can please save your questions for the panel discussion. Let's thank Mr. Ryan Collins. So now that we heard from the AI startup side, we'd like to switch gears and listen to a lightning presentation on the venture side. So our next speaker is Mr. Josh Su. Josh is a senior manager at SK Hynix Venture, which is the venture arm of SK Hynix, a global semiconductor supplier HQ'd in Korea. Josh is an engineer by training and has been working at both startups and big corporations in R&D, product development, and operations before switching career focus to business and venture investment. Josh has worked for both financial and corporate VCs with investment focused on around enabling technologies in AI, data center infrastructure, and sensory systems. Josh graduated from National Taiwan University and had an MS from the University of Michigan, Ann Arbor, and an MBA from Kellogg School of Management. Please join me in welcome Josh Su.
Thank you, everyone, for joining this session, and I think I'll be quick to save more time for our panel discussion. Well, first, apologize, there's no slide. If you work in a memory chip company in Korea, you know how hard it is to send any material out or share anything public. I'll try my best to walk you through to the next, for the next 15 minutes about what we do, who we are, what we do, and share a little bit of what we see in the startup environment in the semiconductor industry. So I assume that some of you might not be very aware of what SK Hynix or SK Group is about. SK Hynix is one of, I think, 95 subsidiaries of SK Group, which is one of the largest conglomerates in Korea. The business range from energy, petrochemical, telecommunication, technology, and semiconductor. SK Hynix is sitting at the semiconductor side. We are a global memory chip supplier. Outside of DRAM, NAND flash, SSDs, we also manufacture CMOS image sensors. Thanks to the skyrocketing memory price, our revenue last year is $30 billion, which places us number 3 in terms of a global semiconductor company, right after Samsung and Intel. So in terms of SK Hynix Ventures, we are quite early in the venture investment theme in the Bay Area. We started the team in 2015 and made our first investment in 2016. We are still actively ramping up our venture investment practice. Our goal is to deploy $25 to $30 million this year, with target of 6 direct investments. I think so far we are well on track to the goal and maybe even exceed target number of 6 startups. I'll talk about that later. And so we are a corporate investor, right? So as a strategic investors, that doesn't mean that we don't care about financial performance, but we also hold responsibility of bring back strategic value back to the company. So we work closely with our business unit and the headquarters and R&D department as well. So we try to align with business objective as well as the bigger corporate strategy. So we don't require direct or immediate business collaboration with our portfolio company or our potential investments, but we help to facilitate business discussion in parallel to our investment discussion. As a corporate VC, that means our investment ultimately need to be signed off by our CEO and CFO. So in terms of investment process, we work with business leaders in each of the business units and the R&D department to form the investment committees and to discuss and ultimately decide whether we go forward with the investment or not. So next, I'm going to talk about our venture investment practice. So our focus, I'll put that into 2 categories. First is direct investment into startups, and the second one is indirect investment into VC funds. And I'll talk more about each in detail. So for the first one, it's pretty clear, right? So we look at the startups that's closely related to our core business in memory technology and CMOS image sensors. We also look into startups that's around adjacent emerging markets. So for example, in data center infrastructure, in the sensory systems, especially on the cars today, in AI and IoT. But we look for enabling technologies, meaning that we don't so much engage with startups that's in the application level, but more technology or IPs with some strong tie to the physical layer or the hardware. Right? So that's kind of related to our company's long-term goal as well. In terms of the venture investment practice, we are stage agnostic, but the sweet spot for us would be Series A, B, and C runs, where we feel comfortable. Typically, a company at that stage is past proof of concept or has some initial customer discussion. Our check size is $1 to $5 million, typically, depends on the stage. And we usually set expectation of 12 weeks from startup due diligence to wire the money to your bank. So we spend about 6 weeks to do product, financial, legal due diligence, and 3 to 4 weeks for that internal headquarter approval process, and additional 3 weeks just to go through the government documentation to wire the money out from Korea. In terms of the region that we cover, the team here, we are a small team of 6 people, all based in Silicon Valley. We cover globally except for 2 countries. We don't invest in Korea, where our headquarters is based. We don't invest in China, which is a country really hard to invest if you're not there. So we have a sister team that's based in Shanghai, China, that looks at the startup ecosystem in China. And then in terms of indirect investment, so we also play the LP role and limited partner role, invest into the VC funds. But we don't so much, invest into the general VC, the big general VC funds, but we focus on the VC fund that help us to increase or expand their coverage in terms of the vertical industry. For example, we invest into the auto tech ventures that just look at the mobility and the car automotive industry. And another goal is to help us to expand our coverage geographically. So for example, we are in IMEC's X fund that help us to cover not only the semiconductor but also in general European region. So another goal for us is just to for deal sourcing purpose, right? So we got the referral from our VC funds, partners from VC funds for co-investment opportunities, and some of the startups that they met might not fall into their investment scope, but might relate it direct to Hynix, and we'll talk to them and take a look at. And the last goal for us is just to build a network, right? So as I mentioned, we are fairly new into the investment theme, and we want to leverage a network, with our VC fund partners, and build our own network in the long run. Lastly, I want to share a little bit about what we see in the startup investment in the semiconductor industry. So there's 3 points I want to cover. So I think we'll touch upon that during our panel discussion. So the first one is AI, right? So we're in the NVIDIA building today, and it's really hard to not walk into a startup pitch and they don't talk about AI or machine learning these days. I don't know if it's good or bad, or I don't know whether that's a bubble when it will burst, but it definitely helped brings a great impact to the semiconductor industry, right? So people realize that to achieve what AI claims that it can do today, they really need a fundamental relook at the hardware level, right? They really need a new jumping innovation in the hardware. So that's why we see a lot of AI-related hardware chip companies, right? I think up to 3 years ago, when I was with Intel Capital, it's really hard. Well, it's not easy to find a semiconductor chip startup, but I think since 1-2 years ago, they're just very many, right? So, and we're definitely going to see a lot of innovation coming out from this space, and I'm excited. The second one is car, right? So, automotive segment is the fastest growing segment in the semiconductor industry, especially when as a memory vendor, how we look at. So, there are, I think we met 30+ LiDAR company, we met 20+ radar companies, startups, right? So. It just, we see people look at the car as a new platform for compute, for storage, for new sensors. So that would drive a lot of innovation and a lot of capital into this space. So that's another area that we see a lot of innovations that, so that, ultimately, right, people still want to have a autonomous car on the road, right? And then to achieve that, there's so much innovation that needs to happen before, we have, autonomous car on the road. And the last one is China. So I just saw a catching headline today that the AI, the money poured into the AI investment in China is $5 billion last year, and exceed AI investment in U.S. last year, which is about $4.7 billion. So I don't know how accurate is the number, but that definitely indicates the bigger trend is happening in China. And I don't want to get into why or the reason, right? So there's a political reason, or definitely Chinese government's influence is significant to kind of revive or stimulate to support their domestic chip and semiconductor company. but we are definitely going to see, especially with the market in China, domestic market by China itself, we're going to see significant innovation from China as well, right? So it's an interesting space to investment as well as start today in the semiconductor industry. I'll be happy to chat more after the panel discussion or during our panel, but thank you.
I think for the interest of time, we'll ask you to keep your questions towards the panel discussion. Thank you, Josh. So I'd like to keep some momentum and introduce our next EC speaker, which is Dr. Kang. Dr. Deng is the CEO and founder of krtkl, which is the first structured platform to bring together top universities, corporations, and VCs globally for innovation and entrepreneurship. Dr. Deng is a seasoned industry executive with 15 years of experience in product, business development, and venture capital. She brings a stellar network from the venture capital and corporate board to startups, such as the innovation and investment arms of Honda, Yamaha, NTT, SAP, Google, Samsung, Intel, just to name a few. Dr. Deng has also been a member of Hillary Clinton's Technology Policy Advisory Committee. She has a PhD in physics and is a graduate of UC Berkeley High School Venture Capital Program. Let's welcome Dr. Deng.
Thank you, Ilko, and thank you, everybody, for giving me an opportunity to present what UFirst Capital is all about. Like Venbo mentioned, I've been in the corporate world for about 15-ish years. Started off from a product strategy perspective, and then gravitated over to the business side of things and looked at the industry from a venture side of things, mainly focused around IoT and cybersecurity. But in the course of taking different roles across my corporate career, I've been fortunate enough to be faced with problems which gave me the idea of creating this platform called UFirst Capital. So UFirst Capital is an innovation hub, as it mentions, that brings universities, corporations, and VCs together. So in my corporate career, I've come across problems where I was looking for, as an example, a facial recognition technology like 7 years ago. And at that time, it was hard to Google up those kind of startups and be able to come up with a list. If I Google such, facial recognition companies today, I'm sure I can count at least 30. And like Josh mentioned, China is at the forefront of some major giant gorillas and unicorns in the facial recognition space today, and for good reasons. So, like I mentioned, UFirst Capital is positioned right where this cross sits. There are a lot of innovation hubs, accelerators, incubators in the Bay Area outside as well that are heavily focused around startups, corporations, and VCs. The idea is to be able to marry academia, the wealth of knowledge and innovation coming from academia, and really position UFirst Capital right where this cross sits. We have a global reach now, and we've been fortunate enough to harness our years of relationships, networks, working across different experts across different geographies. So we have advisors now in Brazil, Malaysia, Hong Kong, Indonesia, India, and China. Like I mentioned, the whole idea behind the platform is to be able to act as an external innovation arm for corporations. And being part of a big corporate, I know that there are really good reasons why corporations are interested and find this kind of a platform useful, particularly for scouting some unique technologies and being able to establish mini consortia outside of their giant umbrella and be able to harness the power of the network coming from academia, from the startup community, and co-investors around them. So we are raising a small venture fund, about $20 million. We have one big corporation, about $60 billion in revenue, that is already an LP, and we are not allowed to speak about them publicly yet, but soon we'll be doing a joint announcement with them. This particular company is a US corporation which is very interested in innovation around smart materials and robotics as it applies to healthcare and smart cities in general. But definitely we are open to having other investors, LPs, with regard to this fund. So I won't go into the fund details, but we are opening up this platform for a corporate sponsorship model at a $200K per year. We'll be giving access to the top startups in the area of interest of the corporate, give access to the advisors, and I'll get to the list of advisors of UFirst Capital. Quarterly events, events will happen under this umbrella. We'll be providing branding at the UFirst Capital's annual Innovation Summit and access to university talent as well as expertise in academia. So this is really not an accelerator where we will have like a mass demo of startups all the way ranging from alternate protein sources to cloud infrastructure. This is really like a boutique innovation hub targeted towards the specific deep domain knowledge, expertise, and innovation that a particular big corporate is looking for in terms of this platform being an external innovation hub for them. From a university standpoint, this particular idea of an external innovation arm is resonating very well. Universities are great teaching and research institutes, and some top universities have siloed deep pockets of innovation as well. The idea is to be able to come up as an unbiased platform, first as that will act as a mode of discovery to start with, but at the same time be able to demonstrate the play of the ecosystem and utilize that ecosystem for creating innovation in different domains. So University of California is a big anchor partner with us. We have a contract signed with UC Santa Cruz where they've allocated their brand new building actually off of Bowers and Scott, so probably 2 stoplights away from here. They will be, this building is available for activities for this innovation hub, but also University of California has provided this building space to host an accelerator, which will help about 25 startups that will be physically located here. They're providing an office space for a year for those startups, as well as actually sponsoring innovation activities and help coming from this ecosystem and acceleration services provided by UFirst Capital for all startups that have a UC affiliation. So all founders who have a student or a faculty or a researcher, anybody who has been a UC alum, University of California is very aligned to sponsoring their presence, office presence in this building, along with acceleration services that will be coming through this innovation hub for those startups. So these are all the universities that are partners with us today, and we've been fortunate enough to have advisors from UC, Princeton, UCSC, Harvard, Babson, University of Pennsylvania, Northwestern Kellogg, Cornell, Singularity, some presence outside as well, Tsinghua University, University of Melbourne, Frankfurt Institute of Advanced Studies, and so on. So this is our industry ecosystem. Again, we have advisors across multiple innovation arms in this ecosystem, And for some of the corporations, we have their venture arm very interested and connected with us. And we have identified advisors who will come at a regular cadence to this innovation hub and talk about their gaps in innovation, so the startups can start aligning their products towards fulfilling those gaps in innovation. That's their goal. In that capacity, Microsoft, Cisco, Honda, Fosun, which is a big Chinese conglomerate actually with presence in multiple domains, including healthcare, fintech, etc. NBC Universal from a media perspective, Global Logic, which is actually an IT solutions provider to all the major retailers you can think of, apparel giants in North America. JD.com, everyone is familiar with, is a big e-commerce player. In Asia, SAP, Samsung, Cyberport is again a Hong Kong-based conglomerate. Cybernaut is a private equity fund in China, again, that has strategically acquired like 10 to 15 angel investment funds under its wing, so they are a partner with us as well. And then Entity, which is a big Japanese, one of the 3 top Japanese telcos, and MetLife, Google. Khazanah is actually a Malaysian government sovereign fund, again, very interested in having a piece of innovation, particularly in AI and machine learning and cybersecurity from North America. So we have been fortunate enough to utilize and harness the feedback and constant inputs coming from these people. Melissa Mayer has been a good friend. She looks at this platform as also a unique channel of innovation coming from this ecosystem that uniquely has these schools, the startups, as well as the corporations together. And then Dheeraj, who's the CEO of Nutanix, which is a very well-known company in the Bay Area. He's been the founder of the company and is now the CEO of the public company in the converged infrastructure space. Mark is on the board of Stanford Medical Facility and is a serial entrepreneur and investor himself. And Dan is the president of the Malaysian Government Innovation Arm. So we've been getting good feedback from our friends with regard to this platform. On the industry advisory board, we have people like Scott McNeely, who's the founder of Sun Microsystems, Sudhir, who's been the ex-CTO of Liberty Global, Chief Product Officer of Entity, ex-CIO of Tesla, and senior execs from SAP, Google, Yamaha Motor Ventures, and we built an university advisory board as well. I grew up actually reading papers of Dr. Krishna from Stanford, and that time I used to be in awe in terms of the work he had done, and I'm now fortunate enough to and feel blessed that he's on our advisory board. So that's on the semiconductor side, but we have a pretty wide experience, I think, domain experience covered through our university advisory board, where we have either people who are in the associate, vice chancellor positions, very tied to the commercialization, innovation arms of their own campuses and their own schools, or people who are top domain experts in a particular domain like computer vision. So this is our presence in Brazil. Some of these corporations, are Fortune 500 corporations like Bayer and government innovation arms as well that are partners with us today. These are our partners from an Indonesia perspective as well. CD Corp is a big retail conglomerate which has about 200 stores in Indonesia and several fintech and entertainment assets. Startup Surabaya is a government innovation arm in Indonesia, and Kyber is a telco veteran run, very Google aligned accelerator in Indonesia. So then we have more partners. I won't go into all the details here across China, Hong Kong, and these are the sectors we are looking at with regard to this external innovation. We're keeping it broad, particularly because there is a lot of intersection of these sectors today. As we look at companies, they are positioned across multiple sectors and are touching on several applications as well. Friends of the firm have been networking very heavily in the venture community, so have advisors across the top venture funds as well, and they look at it as a unique platform because I think it is the first structured platform in terms of bringing innovation from the university ecosystem and being a single point of discovery across multiple universities and schools, along with bringing the usual corporations and the startup ecosystem along. We'll be offering some courses as well, and some of these will be deep domain courses like courses on AI, big data, robotics, etc., taught by the top 10 domain experts in North America in these particular domains, or proprietary courses like the Google Design Sprint course, and I've been a mentor at Google Launchpad for about 2.5, 3 years. So those kind of proprietary courses are open up only to people who are either Google employees or have been mentors to their innovation programs. And I'm happy to extend the umbrella out to this external innovation arm through this platform. Thank you.
Thank you, Dr. Kang. And again, we'll keep our questions towards the panel. Dr. Kang touched upon a few interesting sectors, such as artificial intelligence, IoT, and autonomous vehicles. One of the key enabling technologies for these applications is new hardware architecture that can enable all these new technology. And SiFive is a semiconductor startup company that's making a new RISC-V chip that will become the next disruptor. So I'd like to welcome our next speaker, Jack Kang. Jack is currently the vice president at SiFive. SiFive builds off the most advanced RISC-V cores in the world and delivers the industry's first open source hardware platform. So prior to joining SiFive, Jack held a variety of senior business development, product management, and marketing roles at both NVIDIA and Marvell, with a strong track record of very successful large-scale design wins. Jack started his career as a front-end design engineer with a focus on CPU architecture and design. Jack received his BS degree in electrical engineering and computer science from UC Berkeley. Now, let's welcome Mr. Jack Kang.
All right, thank you. So before I begin, I guess I should ask, how many people know RISC-V? All right, it's pretty good. We're definitely almost at 100%, not quite there yet. So SiFive was founded by the inventors of RISC-V. Many of you don't know, just to clarify, make sure we're all on the same page here, RISC-V at its core, it's free, it's open. What is it? RISC-V is really just the instruction set architecture. So the set of instructions, the specification, if you will, of how to build a CPU, that is at the heart of what RISC-V is, and that is the part that's free and open. Anybody can use it, and anybody can implement it, and anybody can build whatever they want with it. So with that comes a couple of very interesting things that you can do. So for example, you can build your own RISC-V core. You can be a CPU designer, you can design your own RISC-V CPU, keep it secret, never share with anybody, and it's perfectly fine. You can build it, you can tell everybody you're building this, but only use it for yourself. That's also okay. Or, more traditionally, you can build it, you can license it, you can sell it to somebody else. That's also allowed. And because you can do whatever you want, you can license it under whatever commercial terms you want. It means you can also license it under an open source license. So this is where a lot of people get confused about RISC-V, is because there happens to be a few RISC-V implementations that are available in open source. So those are free and open implementations under whatever open source license that they're released under. So the company, SiFive, got its start in Berkeley. So RISC-V was originally designed to be a 3-month project. It was a 3-month research project. At the time, at Berkeley, graduate students at Berkeley actually tape out a lot of chips, and then they needed a CPU to do some of their research projects. In order to do so, they looked at all the architectures that were available to them, ARM, x86, commercial, and for a variety of reasons, both complexity, commercial, the fact that they needed 64-bit, it was decided that the easiest way to actually get going was to create their own ISA for research purposes. So that's why it was a 3-month project to create a very simple CPU for research purposes. And I'm cutting out a lot of parts of the story in the interest of time, but the reason why it's called RISC-V is actually the 5th generation of RISC processors that came out of UC Berkeley, starting with RISC-1 in the 70s by Dave Patterson. So there was a RISC-1, a RISC-2, and then RISC-3 and RISC-4 were called something else. And Dave always regretted not calling it RISC-3 and RISC-4. So when they went back and they built this, that's why it's RISC-V. So it's a Roman numeral 5, not RISC-V. So as a research project, they started RISC-V. They were building multiple cores, so you can actually see here. At Berkeley, they taped out a bunch of different chips with RISC-V cores in them, about a dozen or so different chips. And pretty soon, as this was happening, they started incorporating it into coursework, and people started asking questions about this. Started getting questions from random folks, like, hey, why did you change this? Or why did you modify that? And they weren't really actually changing anything. These were just like instruction sets and homework assignments for students to be like, what would happen if something like this changed? So quickly realized there was a demand for RISC-V, much bigger than what they had thought. So that's when as the graduate students were graduating, to worry what would happen next, so SiFive was born. So SiFive got to start in 2015. So the founders all came from Berkeley. The team is also composed of the original set of research students who worked on these chips while at Berkeley. And since then, SiFive has really focused on commercializing effectively custom RISC-V cores as well as custom chips. So we'll talk about that in a second. So first I'm going to talk a little bit about what it's like to start a company, like really start a company, what that feels like. And then I'll end with a little bit of what we're actually doing as a company now, making it in the world. So on the upper left, you'll see there, when you actually start a company, like, people may work a startup, but if you're actually starting a company, you actually get an office, the first thing you'll realize when you show up is that nothing is there. It's actually just a room. You actually have to get tables and chairs, a refrigerator, get a trash can. You have to make very important decisions, like how often should the janitor come? Once a week? Twice a week? Things like that. So that's kind of the picture of when we just started. I think I was taking the picture. On the right, then you need to get a server. These days maybe you don't, you can just run it all on the cloud. But we started off with our own server for moving it into the cloud, so you see that in the upper right. And then that's kind of the office, kind of more filled out, if you will. You have 10, so I'm the one with the bad posture, slouching there on the bottom left. What do? We are a chip company at heart. We help people get RISC-V stuff, and we also build our own chips. So the very first chip that we built, of course, as a startup, you're on a very, very compressed schedule. You're trying to hit some deadline. You're trying to show it off at an event. You barely get the tape out, and then you realize, okay, in order to expedite this process, we're going to go hand carry the parts back from TSMC. So this is not a very well documented process. It's actually very difficult. You need to talk to a lot of people. We were in Taiwan. That's Yansup. He's one of the co-founders of SiFive, and I took the picture. So Yansup and I had a very nice walking tour of the TSMC campus, which is very, very large, trying to find the right building where we can actually go pick up a box of wafers. Well, we thought it was small wafers. It's a giant box. Now you have a problem. How do you actually bring this box home? Because you've flown all this way, you paid all this money, you're not going to check it in. What are you going to do? The solution was, oh, you're going to buy a seat on the airplane for your wafers. So that's a seat on the airplane so that we can bring it back. This is kind of the fun part, I guess, of being in a startup. You get to do some crazy things like this. I think from the date that this picture was taken, which is the day we were in Taiwan getting the wafers, to sawing it, packaging it, putting it on a board, putting software on the board, and showing everybody this board was 2 weeks. Okay, so that was pretty incredible. Like everything kind of really had to work, and we were counting literally hours. Like we need to drop this off at 8 a.m. so that we can get back at 5 p.m. Everything from the bottom. But you get to do things like that when you're in a startup. So how long for tape out, that's one of the things that we're working on at SiFive to greatly reduce how long it takes to tape something out. So we'll talk about that in a second. Side story, then when Unsub landed, you actually didn't fill out the form properly, which means now you're stuck in customs. We actually were stuck in customs for about 12 hours until we could figure it out because we did not have experience actually filling out the paperwork correctly. Lessons learned. So company now, about 3 years later, we have almost 300 employees, 10 offices. We acquired some things along the way. With world-class expertise, so you can kind of see where it all started. So from that original office, which was actually in San Francisco. So not only were we a very, very rare semiconductor startup, we were a semiconductor startup in San Francisco. Okay, so when I was there, I was jokingly called VP of everything else because I was the non-engineer or the retired engineer. So I really did not appreciate that because all the customers, all the partners, everybody else was still here in the South Bay, as was my home. But anyway, we've now moved to the peninsula. San Mateo is our headquarters. And you can kind of see a very global presence. So as you grow at 300, you also end up with an exec team that is larger than the original picture. That's what happens. So what are we really doing? So we talked about RISC-V. So SiFive as a company, we really do a couple of things. So first is we help chip companies get access to RISC-V IP, so custom RISC-V IP. The second part, and I argue the more exciting part, is we want to make building chips much easier, much faster, and much lower cost. And one of the things here, today we're talking a lot about kind of starting companies and startups, and I can tell you it's the ratio of software companies to hardware companies started, it's really hard to start a hardware company. It's even harder to start a semiconductor company. Now it's a little better in the last year or so if you have an AI in your name or something like that. But one of the primary reasons is, to start a software company, you can fund two guys in a garage, you can give them $100,000, they can come back with a working prototype, things are good. Start a hardware company, start a semiconductor company, how much does it cost to get to that first chip? Right? So now the VC is looking at it, I have to invest $5 million, $10 million, and I'm going to wait a year to get a chip, and then I'll know if this whole thing works. Whereas I can take the same $5 to $10 million and invest that in 20 different software companies. Right? It's just much easier for that to happen. So we're trying to change all of that. So we think there's a couple of trends that are driving the demand and the need for such a solution. So first, on the hardware side, this was kind of in the world we used to live in, where we had predictable performance analysis. Things got faster every generation. The cost per computation kept declining. You just kept going to the next node. Things became cheaper, things became faster, but more importantly, it was predictable. So because of this, there was very little incentive to build any custom hardware. Because by the time you finish building custom hardware, you just go to the next gen of whatever standard thing there was, and it would just be faster, cheaper, lower power. This is really kind of no longer the case. I will stand by the fact that I think Moore's Law is at the least economically dead. Things are no longer cheaper. You don't get free lunches. However, we look at where compute is going. We're talking about going over the edge. Here, this is the increase in performance relative to the VAX over the past 30 years or so of computer architecture. In the beginning, we had CISC constructions, and then we had RISC-style architectures, and then we went to multi-core, and then we had other accelerator types improvements. And really what we're seeing right now is really only 3% year-over-year improvement in performance. So this is why there's a need for more custom compute. This is why whenever we talk about AI and machine learning and accelerators, why people are using GPUs, why people are using FPGAs, why people are using TPUs, what have you. It's all about how do you accelerate compute you have to put in hardware. So this is driving a need for custom silicon solutions. So this is running to counter to the whole first problem that I said, where it's getting more and more expensive and harder to build chips. At the same time, we have this ever-increasing demand for custom silicon. Like, how do we solve these two things? All right. So say we have more custom compute, which means we need more custom hardware because all these applications are different. How do we solve this problem? So the challenge with this right now is as we go to all of these new nodes, the cost has gone exponentially higher. Not just the cost, right? The cost is one factor in terms of the amount of dollars needed for IP, for tools, for math stats, for all those things. But that's just one part. The actual other part that's even a bigger problem is the number of people you need. The amount of expertise you need to build a chip, right? This is just a small set. You need an architect, you need logic, you need an RTL front-end designer, you need verification, you need layout, you need placement route. And we're not even talking like on the business side. You need to have somebody who knows how to call somebody at TSMC so they can accept you as a customer. Somebody who knows the package guys. Somebody who can negotiate the EDA contract. The amount of people you need to start a hardware company is ridiculous. And it's preventing innovation. All right? You compare this to software. Instagram was a $1 billion acquisition with 13 employees. So, you know, we should be like, as hardware guys, like we're all kind of hardware scene, like this should really upset us. Right? Like we're like, hey, hardware is really hard. We're working really hard, and it's like 13 people create a $1 billion company, whereas 13 people, on the previous list I already needed 14. Can't get the chip. Right? So how do they do that? And the answer is, in software land, what they discovered is they built a stack. They built an entire technology stack. So a product like Instagram, a company like Instagram, only needs to build the very top part of their product, and they can leverage everything else underneath. And most often, a lot of these are like open source technology stacks. Right? So we need to build the same for hardware. So using RISC-V as kind of an anchor, as kind of a lighthouse that's drawing people in, what SiFive is building, we're building what we think is the world's first hardware technology stack. It's going to let people build chips much faster, much cheaper, much easier. Right? Called SiFive clusters. So really, all we're doing is learning from software. So rather than being upset, like, let's take what they've done and see if we can apply it to hardware. So a long time ago in software land, what they learned, over here on the side, is that they no longer write their code in assembly. They don't write their code in binary, right? They use higher level programming languages, and then they build higher level programming languages on top of that. So the two kids in the garage can build a $1 billion app called Instagram, because all they have to do is build the app. We don't ask them to rebuild the operating system, or the phone, or the compiler, or everything else. But in hardware land, we still do the same thing. We write in Verilog, which is basically assembly. Right? And we then, after we finish building our chip, we go in and we'll modify transistors individually, like at the GDS2 level, because this crosstalk is too high, or this is, that's basically the equivalent of going in and twiddling with the binary in software land. So how productive can you be? Why do we need so many people? Why does it take so long? Well, it's because we're still working at these lower levels. So what we have to do is raise the level of engineering focus. So one of the really key things that came out of the group at Berkeley, team that invented RISC-V, was not just RISC-V, but entire design methodology. So what they've done, so for example, what we do at SiFive is we don't write in Verilog, we write in a language called Chisel, which is embedded in Scala, which is a higher level language, which then creates Verilog. This allows us to be much more productive. So the teams now, for example, we have a huge variety of RISC-V IP cores. Okay, so we have cores that cover, if you guys are familiar with ARM roadmap, there are microcontroller cores like the Cortex-M, M0, M3, M7, there are Cortex-R, which are real-time cores, there are Cortex-A, all their multi-cores. You know, right now today, we probably have around, I would say 70% of their portfolio already covered. Right? Our entire code base, relatively, if you measure it in Chisel, is something around 10 to 15,000 lines of code in Chisel. A single Cortex-A9, which is one core from ARM, it's 1 million lines of Verilog. Right? So how much more productive can a programmer be if you have 10,000 lines of code versus 1 million? That's just one core, not 70% of their cores. Now, of course, when you can take Chisel and you turn it into Verilog, it expands out to be much bigger. But that's the same thing as when we look at Java, higher level languages versus assembly. So we have to raise the level of abstraction. So what I talked about earlier, when I said what we look for is software should write hardware. That's what we're working on. And then what we're building is this entire vertical stack, this hardware stack that will let folks build chips on their own. So companies can come in with just their IP. Right? You have some unique IP that's going to accelerate the latest, greatest AI algorithm, whatever you want. Well, you know what? You want to put that in silicon. The rest of that chip, 90% of that chip, is really a commodity to you. You need DDR, you need a CPU, you need PCIe, you need, whatever. You need UART, you need I2C. Those are all normal stuff. But in hardware, we make you rebuild it. We make you reacquire it, rebuild it, relay it out. You have to do it all by yourself. So what we're doing at SiFive is an entire design layer where customers can come in, they can bring in their own IP. We have SiFive IP, which comes from the RISC-V cores. We have partners, IP partners, we call design chip partners, that you have access to their IP. We assemble it, we run that on our systems. So we have our servers, our tools, so you don't need to have your own tools, you don't need to have your own cloud, you don't need to have your own servers. And you do all this stuff, and then you can get chips. And the whole point of all of this is we're really focused on reducing the cost to prototype. Not the final cost of production, although that helps, but the cost to prototype. Right now in hardware, the cost to get that first chip is just as expensive as the cost to get like many chips. Right? So in prototyping phase, we're looking at the IP partners, ourselves, everybody kicking in. How do we lower that cost so that more companies can get started to build chips so that they can start their companies? Knowing very well that most of those guys are probably never going to reach production. But that's okay, because we can create 10 new companies who can try and build prototypes. Even if 90% of them fail, we have another new company coming in. Right? So some of these platforms, like we're talking about, we have a microcontroller platform. Today, if you want to get prototypes, you need like 100 chips. That's kind of roughly how we define prototypes. You get 100 chips. Right? These are full-on ASICs. We valve them out, we do everything. How about $100,000 for 100 chips? Okay, $100,000, it's still $100,000, but compared to how much it costs to actually build a chip, it's dramatically low. Okay? So this is an early version. You'll see a much better version of this web interface shortly, but this is the product. Companies come here, you see a product like this, and then you go in there and you can customize your own cores or your own chip. So as simple as clicking some buttons and removing some things, that's how we deliver our cores today. Of course, we have a couple of different templates and starting points, but you go in, you're changing a few things, and then we're recreating the actual design, the verification, the testing, the running, everything on the hardware side. That's really what we're working on. So customers use it, they can get this 5 IP, or they can use the other version and they can get actual chips delivered to them. So at the end of the day, proof is in the pudding. So this is an actual chip that we built using all this automated stuff that I talked about that sounds really good, and maybe you don't believe it actually works or whatever. This is a 28 nanometer chip that we built using our own methodology. It has 5 cores, including our U54, which is our Linux capable. So it's a Linux capable multi-core running at 1.5 gigahertz in 28 nanometers. So this is a, I'd argue, highly full-fledged performing chip, very competitive in the market, which means that you can use automation, you can use design techniques to still build chips that are world-class. This is available, you can buy it, people test it out for themselves. This is the only Linux-capable RISC-V chip currently on the market, so a lot of the software that's being ported for RISC-V is actually imported right against this chip. Similarly, we have one for microcontroller, for RTOS, and other things are being ported for that. So with that, the last slide, the big benefit here is reducing the prototyping costs, means we'll have more design starts. We'll have a brand new ecosystem where more people can provide IP. IP providers have a way that they can sell their IP, because now they can be part of this platform. You can have more customization, everybody can still get their custom chip, focus on what they do best for their differentiation, which means we can have more startups. Each startup doesn't need to have 14 guys, it can be 2 guys, reduce the level of excitement. And most importantly, as an industry, as a hardware industry, we need to increase the level of excitement. Okay, like as everybody else is, if you go to a software conference, I'm like old. Okay, it's like young people energetic, want to try new stuff. Doing hardware things, I'm like young. That's seriously right, because you need people much younger than I who are interested in wanting to do hardware, or this industry will not keep going. Right? So we have to bring excitement back. We have to make it easier for them to start companies. We have to make it easier for them. We have to encourage them to build more things. And that's really what we're working on. Thank you.
Currently seeking startups that focus on China and US markets for SkyChee Ventres. Joseph has mentored over 100 startups both the hardware from Y Combinator, 500 Startups, Labs 360, and Alchemy's Accelerator. Joseph is the co-founder of Labs 360 Hardware Incubator, and previously Joseph consulted with Intellectual Ventures on IP portfolio strategy. So Joseph, would you like to take over the panel?
Sure. All right. Is that okay? Maybe we'll take a quick survey. How many people are in startups in the audience? Not that many. The rest of the people are with big companies. Okay. All right. Any investors in the audience? Fine. Everybody's going to come to you. All right. So we have a very interesting panel tonight. I mean, two from the investor side, two from the startup side. So maybe I start out with Brian. I mean, so we met a couple of times already. How did you come about? I mean, did you just want to do a startup, or you just kind of wanted to bless people?
Yeah, so I guess it was a bit of both. I mean, before we actually started our company, krtkl, actually one of the co-founders and I and a different third guy probably met for 18 months, nights and weekends type thing. Most of the time we were just screwing around, telling jokes and not really doing much work. But the other half of it was brainstorming ideas, coming up with it's kind of the I don't want to call it analysis, but paralysis by analysis, but there's a lot of kind of overthinking what is the right fit, what do we want to do, and going through the whole process. It wasn't like this current iteration of the company and product was just something that was so instinctual that, it was just, now we look back at it and it's kind of obvious, just staring us in the face the whole time, but went through a lot of different cycles of even starting to going to the point of even incorporating a couple of companies and then just letting those fizzle out, terminating them and starting working on a couple of different ideas, anything from apps to robotics to drones to all sorts of other nonsense. We were pretty deep into a big drone project when Bezos made his big Amazon Prime Air announcement during Christmas of 14 or something, or maybe 13. But anyway, yeah. So it wasn't it was a very frustrating process. I guess it's not necessarily an enjoyable moment of an epiphany or something like that. But it's got to come somewhat naturally to you because you can't just go off in some completely tangential. You can go off in some completely unrelated industry, but playing on your strengths both for yourself and ideally if you have some co-founders to kind of play off of, figuring out how you're all going to piece together in the long run is kind of goes a long way towards dictating the way that the company is going to start out, and so that's kind of I wouldn't necessarily have like a great formula for it. A lot of trial and error.
All right. From a lot of startups that I work with, a lot of times the founders actually trying to solve their own problems. So that's the best way to actually get something started, because now you become your own user as well. And then maybe I have a more general question for, in terms of basically today's blockchain, crypto seems to be the hottest area that most of the startup or VC are chasing after. And why would we still looking harder after?
Sorry, what's the question?
The question is not basically the hottest buzzword today is blockchain, right? Crypto,
right?
Deep learning, artificial intelligence, autonomous driving. A lot of them are just pure software. So why we are chasing harder?
Yes, absolutely. So I think I think somebody already spoke. One of the speakers said that. So software is really the pull for the hardware, and it is the rails which helps people see the kind of problem that is going to be solved. And I think that is, it helps people to see which sectors, which area, which problem, is being solved and what is the scope of that problem. And from an investor standpoint, it's important to understand how big is the size of the market and what's the gravity of the problem being solved as well. Now, that said, software is the rails, but really you need the hardware to be able to, make it a complete engine for innovation. So I think hardware is an imperative ingredient, but entrepreneurs should think on what problem they're trying to solve as opposed to just building a hardware company.
Well, yeah, I mean, if anyone knows of any software that can not run on hardware, all ears. But yeah, I mean, it's I think it's a good point. Yes, and a big part of that is is the full solution. I mean, especially when you're talking about high performance software and IP, you need to be that close to the hardware to be able to exceed what's come before it. Not just adding a little layer on top.
So we have a question from the audience.
Yeah, so Dr. Patterson, since we're talking about SiFive, right, has said in the past that he believes good design can make an order of magnitude difference in terms of hardware performance or power consumption, depending on how you do. Yeah, of course.
So Dr. Patterson, who is a retired professor from UC Berkeley and was, SiFive's, he said that in several public forums that he thinks good design can make an order of magnitude difference, either in terms of power consumption or performance. Does the panel still generally agree with that, or have they run into design roadblocks?
So I'll take that. Hello? Okay. Yeah, so I definitely agree, but I think where people get this wrong is like nowadays good design has to blend both the software with the hardware. Like you have to be designing at a system level. And I think that's why there's this need for, when I say custom hardware, we're talking about actually custom silicon, but it's to serve a specific purpose. So if you're designing your software with your hardware together in mind, you can get great efficiencies. Because if you customize specific algorithms, specific things, you can easily get 10x, 20x type performance or power improvements. But if you're just designing one side in the vacuum from the other, then you are going to run into those roadblocks. There's no more free lunch.
Well, since you volunteered, what problems are you avoiding that Tensilica and ARC didn't avoid?
So that's a great question. So this is really one of customization versus fragmentation. And the real benefit of RISC-V is that everybody gets to share in this very common software ecosystem. So we look at the software ecosystem, and this is really what ARM did really well, and all credit to them. Why they're so successful is because they had a giant software ecosystem that all runs on ARM. And what we have here now with RISC-V is it's a common instruction set, a common instruction set architecture that all software can be targeted towards. So here, the RISC-V designers did a really good job of making it a modular instruction set. So the base level instructions are constant, and then there's standard extensions. And then if you want to add in your own custom extensions, there's a place for that reserved in a place that will never run over any of the standard extensions. So this means that all the standard extensions, all the standard software, all the standard tools, all your debug tools, your Linux ports, your Debian, your Fedora, Ubuntu, your RTOS program, all of these things can all be targeting the same common infrastructure. So that's where you get the benefit of the scale. And then you're adding in your secret sauce on top. So I think that's the kind of the biggest difference where if I look at something like Tensilica, is like you get it baked in and then you're running the Tensilica compiler, Tensilica toolchain. Here you still get the entire suite of tools, from open source tools to third-party commercial tools, and then they're for RISC-V. They're not for like SiFive, they're not for like you, they're not for just this one project. So you continue to get the benefits of GCC improvements, LLVM improvements. These things are, these open source projects are continually being maintained and improved because it's mainlined. You continue to ride that benefit.
So I think that's where you get the benefit of the ecosystem, but still have the ability to differentiate your own product.
Anything you want to add to it, Josh?
Sure. So I totally agree with what you're saying, and also what you mentioned early on in terms of lowering the cost for the company, in the hardware company, no chip company, because we do see a changing theme of new startups that one of the components that they're based on their core are based on the open source RISC-V core, and then add to their secret sauce and try to develop chips in a different variety of applications. So we do see more and more companies, developing startups and new chips based on the RISC-V.
So basically, you answered that question. So we had actually Dave Patterson at SSCS in March. The focus for those talks is mainly on technology, but as you said, the ecosystem building and adoption is the main thing, right? And ARM already has that. So what's your strategy to really build that? I mean, you touched on that in what you just mentioned, but you need a lot of marketing and advertisement to get more developers and Linux and operating system level to the level that to get to the level that the ARM is already has that basically base in the market. Yeah,
Right.
What's your strategy for that?
Yeah, so this is a great question that actually kind of ties into when SiFive was started 3 years ago, and I decided to join very early on, and at that point, it was a big risk. It's like, will RISC-V be a thing? Like you said, you have to have this ecosystem, you need all this software, you need all this stuff, and I can tell you one thing is there's no way this would have happened if it was just SiFive. What really drove this this is the open source community, open source hardware, open source software coming together, everybody realizing that it's in everybody's benefit. So if we look at the RISC-V Foundation, which is a nonprofit foundation of member companies it's basically like a standards body for RISC-V marketing. It's made up of over 100 different member companies, some of the largest companies in the world, including NVIDIA, Google, Microsoft, Qualcomm, NXP, Western Digital. So all these large companies are all part of the RISC-V Foundation. And everybody sees that they can all contribute in areas they know, contribute to the open source things, participate in these task groups, and they all derive the benefit of having that being common, and they can build things on top. So, I think it's a huge variety of factors in terms of timing in the marketplace. ARM got bought by SoftBank. ARM, has not been treating their customers the most friendliest environment and creating an environment. A lot of things had to happen, right? There's no magic formula for creating a new ISA. A new ISA only shows up once every 30 years. So this is a really, really rare opportunity. We have x86, we have ARM, and now we really have RISC-V. And I think at this point, 3 years, or actually 8 years into the journey, RISC-V has definitely reached a point where it's definitely going to be a thing with or without SiFive. RISC-V has firmly established itself. The only question now is how quickly will it continue to grow, and which market will it grow in? So this is why all these new markets are very exciting, because it's not just about the mobile phones, if you will, right? It's all these new areas that require new innovation that don't have huge amounts of built-in software, that they don't have lots of software binaries of their stuff that they have to run. These are all ripe opportunities for RISC-V, because RISC-V is about then letting companies bring in new innovations. They can do new things. You can have your own core. You don't have to pick one of 8, options, if you will. You only have this one or this one. You can add your own things. So, I see a lot of the new markets now adopting it. Certainly, it still has quite a way to go to reach the ARM level. ARM as an advanced level.
How much cheaper, can you give a number how much cheaper you guys are compared to ARM?
So that's there's multiple companies who all provide RISC-V cores, as well as companies can always build their own. So the ability to kind of monopoly price goes away. So this means there's new business models had to be created. It's not going to be the same old business model of license and royalty and what it was.
So it's not an apples to apples comparison because the models have to completely change. And so we're talking about how do we enable our customers to customize their own design so they can change all the microarchitecture, so they can change certain things so they can get different types of cores. So it's a completely different way of looking at it. And then companies also look at it as like, now if I choose to change my product in RISC-V, if I use RISC-V, you're making a decision to join the RISC-V ecosystem. You're not making a decision to work with SiFive, right? You're in the ecosystem. Now maybe first round you use SiFive, maybe second round you use SiFive, but if there's ever a time when you want something that we don't have, there's other options, you can build your own. So this makes a much different dynamic in the environment, in the ecosystem competitively.
Let's have somebody else ask us a question.
So this is really interesting. So if you live on the edge, so to speak, or want to live on the edge with a system that maybe integrates some of these technologies, what sort of quantity do you need to have to make this economic? You can say you can buy 100 chips for $100,000. Clearly, that's not. There are few applications that can stomach such a cost of goods. So, do I need to, for my product, in order for your technology to be interesting, do I need to have a demand of 10,000 systems, or 1,000,000 systems, or 1,000, or where does it really make sense to consider to take this road of custom silicon?
So, sorry, this question applies to everybody, but I'll try to run real fast. I think when you look at custom silicon, there's still two parts to the cost. There's the upfront cost, and then there's the per unit cost. And my comment about the prototyping was the upfront cost to prototype is extraordinarily high. So we don't even get to see a whole bunch of new designs or new types of chips that can be built. So that 100K, 100 parts, that's to get the prototyping phase, to prove out the market, so you can have a working sample, go to the investors, raise money, create a company, prove out to your customers, get an order. But then you still have to convert that to production. There's still material costs, mass costs, things like that. So that depends on your technology node and other things. I do think the industry as a whole has been geared towards building like a lot of like one thing. And we're not really geared to build lots of different things. So this is going to be an industry-wide effort. I think we're trying to take on from the IP standpoint, from the design standpoint. We have partners. We still need to work with things. I think there's still a lot of innovation left for tools and for foundries and for other folks to look at different models for people who are not in the field one thing many, many different times. So, okay.
Yeah, I think that I'll just add on to that. I mean, as with anything, it really depends. So obviously, I'll say about as vague an answer as you can get, but not only do you have to take into consideration the upfront cost of taping everything out and the per unit cost of manufacturing going forward. There's massive costs in just delaying your time to market. I mean, if you're taping out something that you can buy off the shelf in 3 minutes versus waiting 6 months to get custom silicon in the house or whatever your guys' talent is. But there's also expertise that you have to consider, and that applies to no matter which solution you're going with. For us, we do ARM FPGA SoC stuff, so we're piggybacking on the ARM ecosystem. That's kind of the nice part of it. But of course, the whole rub with FPGAs, they're not. Every Tom, Dick, and Harry can't program the things. They're relatively complicated. I mean, it's not as complicated as laying a custom silicon, which is being worked on. But that is another consideration. But if it's also instantaneous. I mean, when you push your RTL, to the gates, like you're done. There's your chip. So I mean, yes, you're probably going to pay more for it than you would just stick it in a bunch of $2 microcontrollers all over the place. But then if you consider performance, how critical is it that you need to harden the different IP that you're producing? I mean, there's just so many different layers. It's a very complicated, obviously, equation to figure out. But it becomes easier once the cost to implement these things, whether that's, we were talking about layers of abstraction before, whether that's all the way to the silicon level, or even that matter like FPGA IP implementation. There's some like interesting software tools out there that Intel and Xilinx are always, duking it out on. But, and it's, and then you compare that with things like what NVIDIA's doing. They've definitely won the software battle from that standpoint, and that's why they're the AI kings basically right now. But with that, with the particular architecture they're doing, there's no way getting around the power costs and size and weight constraints and all that kind of stuff when you're sticking, GPUs on things that are taking up tens of watts, that you can do in a fraction of a watt like an FPGA or custom silicon. So there's so many different factors, when it comes to the actual, not only production costs, commercialization, the time to market, the operation costs, all these different things. It's definitely not like oh, I know, I'm sure we're looking for like a 100,000 units, that's the cutoff. Obviously you're never gonna get that, but a lot of things to consider anyway.
One more comment. So I think from an investor point of view, it really lowers the barrier, not only in time, but also, in terms of the size of team that required to deliver a new design for some innovation that we have not seen before. So it also helps us to kind of be more comfortable to playing, to invest in a company that we know, it will take them less amount of time and less amount of money to enable the company to deliver some product and then test the market.
So it's an attempt to, I think, democratize design, and it's more of a tool for innovation as opposed to creating a complete platform with everything thought through on how to scale. It is what's possible with the tool, not really in terms of, not thinking in terms of a particular vertical and then scaling it out. So I agree with Josh that from an investor standpoint, it is a whole suite of tools opening up to what's possible in design.
My question is for Ryan. So how do you compare your FPGA-based solutions to that of GPU-based solutions like Jetson, Gates to Board, which has very less design cycle time, but are recently being used for more computer vision or robotics applications? How do you compare in terms of power and design cycle time?
Yeah, so performance is kind of tricky. It's because it's really hard to get like an apples to apples comparison. If you're just talking about raw compute power, what's not as difficult or not as ambiguous is the compute per watt, like I was mentioning before. So I think you're talking, at least an order of magnitude or more for the most part when you're comparing, basically the number of computations you're doing per second or whatever the metric you're using. Per watt of consumed energy. So that's, in addition, as like an extension of that, if you're talking about using those in embedded applications, there are other considerations if there's a mobile application or a very small application, if you're doing like this miniature robot or drone, or even something that's kind of a tightly integrated piece of industrial equipment, cooling when it starts to become a factor. So do you need to stick a gigantic fan on top of your GPU to keep it cool? Are you using convection radiation? How are you heat sinking that? Getting that heat off, because that's going to be a hard limit based on the amount of computation you can do. So there's other factors, of course, cost, and like you said, one of the trade-offs is from a software perspective, they have all these different paradigms and great tools and support and all that. Pretty big ecosystem at this point to support the GPU side of things, just because it's been used for so much other stuff for all these years. But I think one final piece that's always tricky with GPUs is integration in like mechatronic systems and industrial automation and things like that. having the I/O flexibility to be able to incorporate, multiple different interfaces, communication buses, motors, sensors, actuators, networking interfaces, all these different types of things. That's a huge barrier to get over if you're talking about implementing a commercial system like that, because what you'll run into a lot of times is you get 2/3 of the way through the project and a requirement will change, or you'll realize that actually this interface you thought only required 10 of a certain type of certain number of pins, or actually requires 20. Now you have to go back to your selection of like 5,000 microcontrollers that you picked through the first time that you're going through, and select a different one, and now start not necessarily start from scratch, but reconfigure things, or maybe you got to add a new processor on there, which means you got another software layer, communication layer to deal with. So having that I/O flexibility and the performance flexibility, while also piggybacking on existing architectures and tools, is kind of what we find the sweet spot to be. And there's obviously plenty of applications that GPUs are good for. But even when you're talking about autonomous vehicles and computer vision and things like that, where you're intaking a lot of different data from different sources, different types of data, you want to be able to process that in a parallel fashion in an extremely energy efficient way. FPGAs, aside from the difficulty of programming them, are just going to blow away a GPU for any types of applications like that. Sure. Yeah. Thank you.
Can you share what it was like? Can you share what it was like when you first got your first customers to use your products?
Yeah, so we launched our product via a crowdfunding campaign. So we got kind of all of our first customers all at once, which sounds great, but in reality it's a total nightmare. We wouldn't be here today, obviously, if it wasn't for the crowdfunding campaign. We would have launched in a different way, probably, and whatever, things would have worked out differently. But when you publicly expose yourself like that, you're taking on a lot of burden, I guess I would say, when it comes to, we're still working on delivering one of the products we originally promised. It's like on the manufacturing line right now, a few miles from here actually. We're working on delivering it 3 years after the fact. And you can imagine 3 years of 3,000 people asking you what the hell's the matter with you, what's taking so long, are you guys stupid, what, if you give my money back, is this a scam? It's like every possible thing you can think of, and even a lot you can't. It's really draining. On the flip side of that, we've had some positive but some negative experiences with commercial customers as well. Our hardware business model is really based around, we want to sell you a thing, a snickerdoodle, but what we want you to do with it is now take that snickerdoodle, put it into a product that you're making, and buy 1,000 a month from us, or more, or whatever. So that part was helped by the crowdfunding campaign because it got us exposure, a lot of media coverage and all that kind of stuff. If you ever want to start a consulting business, just launch a crowdfunding campaign. You get a lot of opportunities you would never otherwise come across, again, for better or for worse. One of the tricky parts about that, though, is, in our case, like I was mentioning before, we do engineering services to kind of help facilitate that process of integrating these systems and getting our product in there. It's the dream of kind of the whole, I'm going to work on my own at a consulting gig, and I'll have all this extra time and money because I'm setting my own schedule, and then I can catapult off of that, and it'll be right at the glory. Is like a total pipe dream. We did it like the other way around, which is already even worse, because then we started like right out of the gate with however much money in technical and financial debt to get this product off the line, and also keep the lights on, not starve, and not have all these people, burning down our building or whatever. So, anyway, I'll kind of speed this up a little bit, but lesson learned, we actually worked with the company for a year and a half, 2 years on getting their product to market. further a ton of our own time and capital and all the rest of it. And they were paying, it's not like we're not working for free, but what ended up happening is we got them in the market, we got them just started their production runs, and then they canned the whole project and said, we're going to work on something else. This didn't work out, blah blah blah. So we take on a lot of risk for a reward that might not ever come, and now you just set yourself back another couple of years, and whatever other opportunities that might come along the way. So it's very, you got to be really picky with the opportunities that come up. You don't want to just say yes to everything because you're bound to get burned kind of doing that. And I don't know. There's a lot of different lessons to take away from all of it. But I don't know if that answers your question or just scares you away enough to ask more. But yeah, that's sort of part of our experience. It's not all like rosy, not a great thing, but you learn from it and move on, and then hopefully something good comes of it in the end.
So unfortunately, I think it's coming up to 9 o'clock. We have to clear up the room pretty soon. So maybe 1 minute closing statement from each of the panelists. Starting with Josh, what do you see in terms of future, in terms of hardware innovation?
Sure, that's a good point. I think for startups or entrepreneurs here, it's relatively easy to create innovation or a new technology, but it's really hard to build a business or a company. Right? So along that journey, you need a lot of help from the team, from the capital point of view, from your personal investment. So looking forward to share more with you guys after this event, and feel free to ping me afterwards. Thanks.
Yeah, I kind of talked about the company. I think just if you have an idea that you really believe in, you should go for it. And it's not all in your control. A lot of things are you need things to fall in place, but you have to be there when it does, so you take advantage of it. And then when you see it, then run as fast as you can.
I think it's a great time for hardware innovation because there are a tremendous amount of applications that are driving that kind of innovation. And there's basically a new white space created with different applications of software that are creating the rails for the hardware to come in and be a complete solution solving a problem. So I think it's a great opportunity now that has opened up through AI, particularly through autonomous driving, and urban mobility as a sector, and also blockchain.
It's the hardest thing you'll ever do. It's like not, I can't even, to give you an idea what my night looks like, I'm going to get on Caltrain at about 10 o'clock and then have an hour-long phone call on the test bench for a new piece of production hardware that if it doesn't work, we're completely screwed. And we're going to be out of money in like 2 weeks. So, and I'm not joking. So, it is funny though. So, it's by far the hardest thing you'll ever do. I wouldn't go as far as say I wouldn't recommend it because it can be very rewarding and we'll see what happens. But, sometimes the 3 people in a room, 3 years ago, doesn't turn into a 300-person company. Sometimes it stays 3 people in a room, and you're still stuck with manufacturing and supply chain and financial and engineering and sales and distribution and every possible problem you can ever think of. So it's not for the faint of heart, I guess. But it's I would not want to start a software company. So you can take it for what it is. It's awesome and it's super exciting. There's nothing like the feeling of getting a new piece of hardware. I'm about to experience it tomorrow about 1 p.m. New piece of hardware and you open it up, it's like it's like a kid on Christmas. You just bust open the box and it's so exciting to get this piece of hardware that you've you pour your heart and soul into it, and you just pray it turns on when you plug it in. But yes.
All right, so I'll just close up. Last week we had the celebration of Moore's Law milestone that we put together at the Computer History Museum, and we quote the chairman from the Computer History Museum, Dan Lewin, he said, every piece of software has to run on something. So until the software doesn't run on software, we still have to create hardware. So thank you very much for all this spending time tonight.
Anybody last copy?
Will the slides be